everyone. Our topic, theory of electrolytic dissociation and hydrolysis. The report was completed by the student Amantai Akulpa, Orynbek Asemai, Turganbekova Saltanat and Kurmankul Aruzhan. Svante Arrhenius was a Swedish scientist, originally a physicist, but often referred to as a chemist and one of the founders of the science of physical chemistry. The Arrhenius equation, lunar crater Arrhenius, and the Arrhenius labs at Stockholm University are named after him. Arrhenius theory of electrolytic dissociation. In order to explain the properties of electrolytic solution, Arrhenius put forth in 1884 a comprehensive theory of electrolytic dissociation or ion theory. The main points of the theory are: an electrolyte, when dissolved in water, breaks up into two types of charged particles, one carrying a positive charge and the other a negative charge. These charged particles are called ions. Positively charged ions are termed cations and negatively charged as anions.
The processes of splitting of the molecules into ions of the electrolyte is called ionization. It has been observed that electrolysis do not ionize to the same extent.
When an electric current is passed out, the electrolytic solution is positive ions move towards When an electric current is passed out the electrolytic solution, the positive ions move towards in cathode and the negative ions move towards in anode and get discharged. Electrolysis occurs. The ion is discharged always in equivalent amount, no matter what their relative speeds are.
Limitation of Arrhenius theory. Oswald's relation of love with based on Arrhenius theory isn't applicable to strong electrolysis. Strong electrolysis conduct electrolyticity in fixed state in absorb of water. This is in concentration of Arrhenius theory according to which the presence of solvent is a must of for ionization. Arrhenius theory assumes independent extents for ions but finds accord for the factory which and infinite for mobility of the ions.
Of the salt with water, whereby the salt is dissociated and decomposed to form a weak electrolyte called hydrolysis. Hydrolysis is a reverse of neutralization.
There are four possible ways of forming salts. First, if the salt is formed from a strong base and strong acid, then the salt solution is neutral, indicating that the bonds in the salt solution will not break apart, indicating no hydrolysis occurred, and is neutral, pH equals 7. Second, if the salt is formed from a strong acid and weak base, the bonds in the salt solution will break apart and becomes acidic and hydrolysis, pH less than 7. If the salt is formed from a strong base and weak acid, the salt solution is a basic and hydrolysis, pH greater than 7. Fourth, if the salt is formed from the weak base and weak acid, will be hydrolysis, but the acidic basicity or neutral depends on the equilibrium constants of Ka and Kb. Examples for possible ways forming of salts. In the first, salt was formed of strong base and strong acid. Hydrolysis does not occur. In the second, salt was forming a strong acid and weak base. In this reaction, pH less than 7, and this reaction is a medium of acidic. In the third, this salt was formed of strong base and weak acid. This is reaction pH greater than 7, and the medium of reaction is a basic. In the fourth, this is salt was formed of weak base and weak acid. pH equals 7, and the reaction's medium of neutral. Hydrolysis constant. The general equation for the hydrolysis of a salt, applying the law of chemical equilibrium, we get K equals concentration HA multiplied concentration BOH ratio, concentration BA and concentration water, where K is the equilibrium constant.
Degree of hydrolysis. It is defined as the fraction of the total salt which is hydrolyzed at equilibrium. For example, if 90% of salt solution is hydrolyzed, its degree of hydrolysis is 0.90 or as 90%. It's generally represented by H. Conclusion. The electrolytic dissociation is observed only with substances having ionic crystal structure or strongly polar bonds. The aqueous solution or this substance and the melts of the ionic compound conduct electricity. They are called electrolytes. Hydrolysis is a chemical reaction that involves the addition of water molecules to a molecule, resulting in the breakdown of that molecule into smaller parts. Thank you for your attention.
Pour 2 ml of distilled water in the 6 test tubes. Add a neutral litmus solution to the first test tubes. Add a phenolphthalein solution to the second test tubes. And add methylaran solution to the third test tubes. First 3 test tube, add sodium hydroxide solution. Other 3 test tubes, add potassium sulfate. Pour a litmus solution into 3 test tubes. First test tube, add a few crystals of potassium chloride. Second test tube, add a few crystals of aluminium chloride. Third test tube, add a few crystals of sodium carbonate. Pour 2 ml of bismuth nitrate solution into a test tube. Gradually dilute the solution with distilled water and absorb the precipitation.